Technology showcase, and he is none other than, we have the next speaker, whom we will be inviting. And this would be the Zhong Yuting, AI expert from HPC AI Tech. Let's give her a round of applause. Thank you.
Good morning, ladies and gentlemen. Welcome to the sharing session from Closal AI team about our Closal Llama 2, which is an efficient domain-specific large language model solution. So today's sharing including 3 parts: why Closal Llama 2, how Closal Llama 2 works, and what has Closal Llama 2 achieved. Now let's start with the first part. In this part, I will explain what is Closal Llama 2 and why we need Closal Llama 2. As the wave of generative artificial intelligence driven by ChatGPT surges, there are many large language models are open sourced. And Llama 2 from Meta is one of the most famous models. However, these large language models usually require high cost, such as it may cost $1 million for training resources, and the whole training process will become time-consuming. Another problem of this large language model is that it's lacking domain-specific knowledge. So, when the demand of building domain-specific large language model increased among the companies and the developers, there are some challenges we needed to overcome. First, for example, the high-quality domain-specific corpora usually is limited, and this domain-specific knowledge in pre-trained-based model is insufficient. And sometimes there are some undesired performance on domain-specific understanding. Some fine-tuning methods such as SFT or LoRa, it actually has the limitation in effectively infusing the domain-specific knowledge and capabilities from the base model. So here, our Closal Llama 2 is proposed to deal with this problem, and we aimed to build the domain-specific large language model be more cost-effectively. So now I will explain how our Closal Llama 2 works. And actually, we mainly use the Closal AI, and we propose our domain-specific large language model solution. So what is Closal AI? I will briefly explain to you. Actually, our Closal AI is the intermediate bridging the hardware and the framework. The framework such as the PyTorch, Hugging Face, and the Closal AI has high performance and efficiency with lower cost. And we use the Closal AI in our training process for the Closal Llama 2. And here are some examples that show the high performance of Closal AI. We can see that our system open source a low-cost pre-training solution for Llama, which has 65 billion parameters. And the whole pre-training is accelerated by 38% compared to our baseline. So I think it is an excellent improvement. So there is another example that we also accelerate the 70 billion parameter model, which is Llama 2 model, and the whole training is accelerated by about 100% compared to our baseline. So by using this Closal AI, we improve the efficiency. So next, here is the Closal AI fully managed ML platform, which we used to the previous example We actually finished this example on our own fully managed cloud platform. And if you are interested in our cloud platform, welcome to view our official website listed at the corner. So next, this is the important part of today's sharing, the domain-specific large language model solution. Here is the overview of our Colossal Llama 2's pipeline. Actually, our Colossal Llama 2 is a derivation of the Llama 2, which is designed to accommodate both Chinese and English. And in order to improve the Chinese capability of the Llama and also preserving its English capability, we propose the continued pre-training on the Llama 2 using the both Chinese corpora and English corpora. And I will introduce our technical details in 3 aspects, which is the dataset, the tokenizer, and also our training strategy. Here comes the dataset and the tokenizer techniques. For the datasets, actually we use all the training data are collected from well-known public datasets. Large language model like Llama, actually they are trained on very high quality datasets. So there are 2 key factors during our dataset preparation. The first is the composition of Chinese dataset and English dataset. The other one, of course, is the quality of the dataset. Here I list the diagram shows the whole process of our data pre-processing. So apart from the heuristic rules and the deduplication, we also add our quality filtering and selection to get the high quality dataset. And as for the Colossal Llama 2 tokenizer, we first extend the Llama 2 vocabulary size from 32,000 to 96,000. And we also initialize our new word embeddings to adapt for the original Llama 2 model. By extending the vocabulary size, actually we want to improve the compression size of the string sequence and also the integrity of the information. And before we made the final decision of our vocabulary size, we also strikes a balance between the substantial vocabulary and the training efficiency with limited resources. So apart from the datasets and the tokenizer techniques, there are 2 other highlights in our training strategy. First, we propose the multi-stage training. We propose this training method in order to enhance the model performance and harness the full potential of the original Llama 2. And it is dedicated to unlock the model's capabilities over 3 training stages. The first training stages is the first stage will be the large-scale pre-training stage. In this stage, actually, the model has masters English knowledge. And in our project, actually, this part is completed by the original Llama 2. And in the second stage, which is the Chinese knowledge injection stage, in this stage, we will introduce high-quality Chinese knowledge to our model. So in this stage, we can improve the model's understanding of Chinese knowledge, and also it will learn the new added Chinese words mentioned in previous vocabulary. And the last stage, it will be the related knowledge replace stage. This stage is interesting. We just replace the knowledge in the question and answering format. And we aim to improve the overall performance of the English capability and the Chinese capability. And this stage also can alleviate the catastrophic forgetting problem, which is a difficult problem in this area. And after following the whole multi-stage training process, we found that the model shows great improvements in both the capabilities of Chinese and English. So there is another training strategy we proposed. The name is bucket-based training. So why we propose this strategy? During the experiment, we found that the continual pre-training is very sensitive to the data distribution. So the data balance and the ordering is very important actually. So we first divided each subset into multiple distinct bins, and later these bins will be merged into data bucket. So in each data bucket, there will be one bin from each data set. So using this training strategy, we can achieve a more balanced distribution and also exert the control over data sets ordering. So after introducing about these technical details, actually based on the previous process, we can propose a more generalized domain-specific large language model solution. Here is the pipeline. So actually, we can start with any general large language model. That means we can change to other model other than the Llama 2. And we can follow the process to perform knowledge transfer in any field. And the whole process will be extremely fast with low cost. And it also allows for the cost-effective construction of lightweight domain-specific foundational large models. So here I will introduce what has the Colossal Llama 2 achieved by now. I will show you the benchmark collection and the community impact. Our Colossal Llama 2 actually has undergone continual pre-training with only 8.5 billion tokens over a duration of 50 hours. And the overall cost is less than $1,000. That means by using our solution, you can achieve the similar performance as those large models cost millions of dollars. So I think that's very excellent. And we can see from the table, our Colossal Llama 2 has competitive performance among all 7B models. And first, for example, we can see the MMLU ranking, which is to evaluate the English capability of the models. We actually overcome the catastrophic forgetting problem because we can see the score is much higher than the original Llama 2. And as for the Chinese capability, our performance actually is better than other Chinese localization model based on Llama 2. And when compared with the original Llama 2 model, actually we have a huge leap in Chinese language proficiency. Other than the rankings here, so our Colossal Llama 2 also have a huge impact in the community. When we released the Colossal Llama 2, actually we ranked the top 1 repository in the GitHub trending. And we also get over 186,000 downloads on the Hugging Face within just 3 weeks. And the more excited is that our base model is also selected as the official as the baseline model for the Europe's official challenge. So if you are interested in our model, you can download either from the Hugging Face or the model scope. This exciting job is done by our Colossal AI team. So at the last, I want to introduce our team. So Colossal AI has fast grown into an open source community with supporters and stargazers from all over the world. And we aim to achieve optimal performance and cost saving for large neural networks, such as including the training, the inference, and also we provide the fine-tuning with our Colossal AI software. So please stay tuned to our upcoming AI solutions and applications. That's all about our today's sharing, and welcome to visit us at booth A03. And if you have any questions, you can ask free. Thank you.
Thank you so much. Let's give her a round of applause. Thank you for your insightful sharing.